All right, so let's start. Welcome, everyone. Welcome to the first ever Confluent hosted Bay Area Kafka Meetup. My name is Guozhang Wang, and I'm a Kafka PMC member and committer. And as you know, today we have a very interesting set of topics from Confluent as well as Uber. And as for the first topic, so you know that at Confluent, we are not only working on Apache Kafka, but also working on a lot of interesting problems in stream processing, cloud computing, and the distributed systems as well. So Joseph Rea is actually one who is working on visualizing messages in Kafka. So with that.
Cool. All right. Thank you, Guozhang. All right, cool. So like I said, I'm Joseph Rea. We'll get to why I'm here in just a sec. But before we get there, I just want to sort of set the mood for what we're going to talk about and kind of why it's interesting to visualize Kafka messages. So let's see if we can get this to work. All right.
We got a winner! We got a winner! Oh, Joel Miller, you just found the marble in the oatmeal. You're a lucky, lucky, lucky little boy, because you know why? You get to drink from the fire hose! Okay, you ready? Open wide! Joel Miller, let's hear for him!
That guy in the shirt? That's Kafka, and the little kid's the front end, right? So who am I? I'm Joseph Rea, right? I'm a software engineer here at Confluent. I worked at LifeLock for a little while, working on growth stuff, not so much the core business. And more importantly, I ended up building the thing that I'm going to talk about over the next half hour or so. So when we take a look at Kafka, right? The base use case here, right, is topics, right? It's just a stack of things. And so when we look at that, we say, okay, that's interesting as a stack of things, but what if we could put those stacks of things together, right? That's effectively what streams and tables, right, are going to let you do. All right, so imagine that we are a made-up electric car company, and we use like letters for our model numbers, just randomly like X, Y, and S or something like that, right? And so we have this factory, and this factory can break, unfortunately, right? We want to ask questions like, is the production line working? What actually is going on inside of that production line? Are my robots working? Is there some breakage somewhere, right? And this effectively, right, is a huge amount of data, right, that's flying through, right, our topic as it were, right, or stream, right? You could use face for a stream, right? It's one single event. It might cause an outage, but sort of after that gets resolved, we can just forget about it. We don't really care, right? And this same made-up electric car company, right, might have a website, and you can potentially order your car through this website, let's say, right? And wouldn't it be amazing if you ordered the car through the website and super efficiently it made it all the way into production, right? And so you could make the assumption that, let's say that you have your 3 models of cars and you know that you're gonna have 10 red cars coming out off of the production line. And the only thing that really changes are the options. And so all you have to do is configure those little options, and then your car's ready to go, right? You have used sort of this streamlined effort, right, to make your cars easier to build, right? And so when we look at a table, right, orders would be sort of falling along those lines, right? I can go update an order. It probably has an order ID, right? But suffice it to say that that would be a table, right, in this world. So when we look at trying to actually see these things, we run into a lot of problems. The least of which actually is our eyeballs. So MIT did this really interesting study where originally, prior to this study, they thought that the human brain is not able to register an image faster than 100 milliseconds, right? So we flash some cat picture and we like, I definitely know that's a cat, right? But what they found was that people can actually see it a lot faster, right? And so basically what they did is they took their subjects and gave them a list of either 6 or 12 images and found out that they, at least better than chance, that was their control, is just random guessing, was that they were able to drop the exposure time of the image from 80 to 53 to 40 to 27, and then finally 13. And 13 effectively was the fastest rate that the monitor could flicker that image while they're still able to see it. So the human brain could see effectively, according to this study, about 13 milliseconds, right? So if we look at that in records per second, right, which is usually the metric that people use when we're looking at Kafka, our eyes can only see 12 per second, right? And so on one thread with no replication, I found this interesting blog post by a fellow named Jay, and he said that you can produce roughly 800,000 100-byte records per second, right? Which you can't see, right? Even if they're these awesome, like, little tiny cat videos, okay? And so when we are looking at trying to visualize this, if you're going to take anything away from this talk, I just want to be sure that you guys know that 821,557 is larger than 12, okay? But what if we actually tried to think about seeing all 800,000 of those, right? And so users that use Kafka, right, are not necessarily going to be sure that they do or do not want to do that, right? They're going to think like, oh, I want to see everything. I just want to see everything. I don't really care what it is, right? So if that is the assumption that we go with, do we even have options to try and do that? From the HTTP perspective, as a front-end engineer, right, this is something that I want to sort of explore and then try and figure out if this number is even possible, right? And so we need to figure out a way to deal with these records per second. If we can't get 800,000, or yeah, 800,000, right? How close can we get? Is there a number? Is there an upper bounds? I'm not really sure, right? But when we start looking at the information or the available things that we can do with it, the most obvious one is just don't, right? I'm going to request 1,000 messages, and 1,000 messages is all that I ever am going to care about to the user, and so I'm going to give you 1,000 messages. I don't know where they came from. They could have been from the earliest. They could have been from the latest. They could have been somewhere in the middle. They could be just a mishmash of whatever, right? And so that's not really a good solution, right, to just being able to see those messages flow through, right? We could use curl, right? Use the CLI. Super dope. So kind of complicated to use, but it's by far the best option. My favorite quote of any engineer that I've ever worked with was a guy that said, the front end should have stopped at curl. And over my 10 years of experience doing this, every single time I'm like, man, he was definitely right. He was definitely right, right? And so the two big ones that people usually stick to, right, as the front end thing is the long poll, right, or polling, right, and WebSockets. And so we're going to talk about all of these, those two specifically, in a good amount of detail, but just understand that the long poll has variable rates that ends up being a little bit rough. Load management, right, since it's like the Apache server, right, you end up having some weird protocol problems with that. But anyway, okay, so when we think about long polling, we want to talk about cost first, right? And so usually when you think about long polling, right, you don't think about the request headers that are in these things, right? And so if we take the case of 1,000 users making one request per second every day for a month, which is not a lot of users, and it's actually not a lot of requests. It ends up being about 80 gigs a day, just in data going out. So if we take a look at Amazon and plug that number into their calculator, it's 225 bucks for nothing, because it's not messages, it's not images, it's literally just the request information that we are giving to, or getting back from the actual server, right? And so if we look at the Confluent cloud product, we actually spend $112 every month if we only had 1,000 users and they make one request per second, right? And so this gets exponentially worse, right? So in the case C, where you have 100,000, just in headers, right, you're spending over $16,000 in order to do this. The other thing that ends up being sort of a bad situation is the dumbness of polling. What I mean by that is, so let's say you hit the backend server, right? There is some amount of time before the backend does whatever it is going to do, and then it returns information, right? So in another totally theoretical situation, let's say that you make a Streams app that monitors to make sure that Kafka works, just as like a totally made up example. And so you want to stress test like how much data you can actually get in terms of figuring out whether or not Kafka, the producers and consumers and all that stuff is actually working, right? There is an upper bounds that it is possible to hit where the backend, at least in this made up monitoring app, where it takes 40 to 60 seconds for the data to actually respond. The reason why this is, right, is the backend is doing an n number of requests. So let's say you have a list of 40 topics, right? It's going to request this state store for that stream 40 times to be like, what is the throughput of this topic? What's the throughput of this topic, right? And so that amount of time when it comes back, right, you are actually on the front end refreshing every 5 seconds because that's the poll that you want to keep up to date, which means every 40 to 60 seconds, you're effectively creating 7 requests that are never going to get resolved, right? So what is happening is you go from, in my ideal world, everything responds in a great time, to DDoSing yourself because the backend's taking so long to come back. And there are ways around this, right? But effectively, unless the server can tell you, right, that I'm really backed up, there's a ton of data that I'm getting, like my brokers are really slow, you have to stop asking for this data so often, right? We need a better solution, right? We need sort of a back channel. We need to go backwards, right? To be like, hey, front end, please stop doing that. And so the two-way communication, right, that most front-end developers think about are WebSockets, right? And so the interesting thing about WebSockets is usually people say like, oh, it's really new technology, right? And it's like, well, it's actually from 2011. It was when the first time it went into Firefox, right? So that's a long time ago, sorry. And then the other problems that you end up having, right, is that clients have to control the integration, right? So instead of a regular REST interface, right, where it's like very stateless, right, and you can do all kinds of stuff on the back end and the front end, if you're using just pure WebSockets, right, the fire hose, as it were, right, in our case in the video when we started this thing, right, the client has to be able to deal with that, right? The other problem is sort of getting WebSockets to build because they are, in the browser, a static file, right? A static file that gets generated into some other sandbox, right? And so it doesn't have access to the actual browser window. There's a bunch of different things and communication protocols that you have to use. And so you build them in a very specific way. The other problem that ends up happening, especially with like large organizations, if you're familiar with like the Cisco Meraki or something like that, where like it'll strip out SSL certificates, it won't allow you to proxy and stuff like that. So the other problem with WebSockets is just like it's terrible with proxies. And that's another thing that we sort of had to stay away from due to how colossally bad it is. But we do get the fact that we can tell the server to do things, which is great, right? We can be like, hey, can you please give me this back pressure? Or the server can tell us, hey, stop requesting that so much, right? And so there's a lot of future applications that aren't built yet that by using WebSockets, we're allowed to do. The other thing that ends up being extremely useful in this case, right, is we are using an event stream to render an event stream. And so when you have parity on the front end and the back end about this is the technology and this is the architecture that we have, it ends up making much more sense in terms of the product direction and the things that you think about. For instance, if you're thinking about an event stream, you usually think about it going forward, right? You never think about it going backwards, right? And so one of the things that this sort of ended up solving is like, so we want to be able to go backwards in Kafka, right? Which is like, well, okay. I'm not really sure how you'd go about doing that across multiple partitions, right? Because it's an event stream. And it's like, okay, this is a very easy case to make now, right? And the other thing that WebSockets allow us to do is handle the load, as it were, right? So if you imagine long polling, right? Let's say you poll every 1 second and you get 1,000 messages back. And every single 1 second, you get 1,000 messages back, right? But the throughput on that topic is 100,000 messages, right? You are just building up, right, the fact that you're never going to get to the most recent one, right? Versus in the world of WebSockets, it's just a fire hose. It's just going to go however fast you can handle it is how fast it's going to go, right? And so when we take a look at a practical example, right, of the message browser, a message browser using WebSockets, right? We basically started with the base case of, so we don't have a way to visualize topics right now. So what we're going to build is a way to visualize topics, right? Ready to visualize messages inside of a topic, right? And this can fail absolutely spectacularly, which I actually hadn't known about until we started doing this, all right? So basically what would be happening here is you have effectively a bunch of messages, right, that would allow you to update them depending on how they actually show up. And so basically what would happen from a resource perspective is that whenever we're doing about 1 message a second, the data generator is that I used to produce this is basically pegged at about 100% CPU on my MacBook. And so basically at 100% utilization, we're using about 18% inside of the browser to actually update and render that stuff. All right, cool. And so if we up this to 20 messages per second, right, it still renders, but we start noticing a little larger usage of both the CPU as it results in the browser, but also the worker, the extra piece of information that actually renders the rest of this in its own little process thing. And so when we are looking at 20 messages per second, right, through the browser on the main UI thread and stuff like that, it's still rendering, but it's consuming a ton of resources, right? And so when we look at 100 messages per second, we see that the browser totally locks up. And by totally locks up, I mean you can't click on anything. You can't navigate away. You can't refresh the page. There is nothing that you can do. The browser is effectively locking up this particular process at about 200% utilization, right? In both the Chrome as well as its own internal processes, right? And so when we hit this 100 messages a second, like there's literally nothing that you can do at all. And that's bad. I did this as sort of a, how far can we actually get with this current implementation using WebSockets as it exists right now? We just want to show messages. That's all that we want to do, just show messages, right? And so we found about 5 messages per second. We're okay. You could do things. It's not lagging or whatever. But once we start slowly creeping up, we really start seeing some huge pain points. And then eventually we just die and crash, right? And so when we are looking at sort of our upper bounds of this, so we're looking at 50 messages per second, which is effectively more than the human eye can see anyway. So that's good, right? No, not really, right? Because when we look at just the base case of no replication, 1 thread, right? We're looking at 800,000 of these things, right? And so we need to figure out a way, right, to offload this onto something else, right? And so the way that you end up doing that is through web workers, which we'll get to in a sec. But first, so that's one problem that we have. We've got one problem. We can't use 100% of the CPU on the main thread. That's bad, right? And so if we just refactor with web workers, makes a lot of sense. We're still showing messages, right? But can we do better, right? Is there something that we could actually do to help people understand what a stream is and what a table is? Like similar to what we talked about before. It made a lot of sense talking to a bunch of engineers, right, about streams and tables. Kind of makes sense, right? Because we've either seen them or heard about them colloquially or whatever, right? And so you sort of have to step back and say, okay, so we have this weird technical engineering problem, right? But is there another problem that we can try and go solve, right? And yes, there is. We can visually explain and visually show what a stream is and what a table is. And so the way that I like to look at this is these two things. Staring at a highway, just blankly. Stuff's going by. Stuff's going by. Then every once in a while, you'll see like a Porsche or a Ferrari or like some old Westfalia van, and you're like, that's interesting, All right. Ooh, Ferrari, right? And so it's like, okay, so that, when I think about it, is exactly what I would want to see if I was looking at a stream. I don't care about everything, but then all of a sudden, I really care about that, right? And so that's generically how I think about visualizing a stream. Keeping track of the cars, the colors of the cars, the model of the car, right? That's how I think about a table, right? At any point in time, right now, right? Okay, I saw a red Camry. I saw that Westphalia van again. I saw a deer. That doesn't count, right? And so keeping track, a tabular list of the things that you saw, right? That's a table. Okay, so if we take a step back and say, okay, generically, how do I quantify what I've actually seen, right? And you kind of have to ask two questions. First off, how long have I been staring at this highway? And in the last 15 minutes, how many red cars have I seen, right? I'm able to start getting insights out of just the stuff that I was kind of looking at. But when I put time to it, it's like, okay, if I have time and I know what time this happened, right? Say it was 15 minutes ago I saw this red car, right? 5 minutes ago I saw this red car, right? It's a different red car, and I know that. And then in the last 15 minutes, I need to see an aggregate tabular list of those kind of things, right? So taking that sort of a step backwards even farther, right? In order to visualize a stream, we need to show a user information in their stream as it relates to time, right? And then we need a way for a user to take a snapshot in time that updates with the relevant changes. When we hit this thing, right, we still have to remember that other problem that we had, where it's like we had 100 messages per second and we still couldn't do anything. And so we got to solve that problem engineering-wise, right? And so to give you a little background about that, right, we need to talk about the main UI process, right? And so pretty much anything that I've ever worked on only needed one UI process, right? While rendering JavaScript in React is expensive and making gigantic XHR requests that take a really long time to come back is very expensive, you can do all those things asynchronously, right? So it really doesn't matter how long those things take because it'll get done eventually. And since it's async, you'll still be able to scroll. You'll still be able to do all the things that you need to do, right? And this is actually one of my favorite things. There are like a lot of upvotes, surprisingly, for use cases for web workers. Because again, until I came here and was like, there's an event streaming platform that can do 800,000 messages per second. And it's like, well, I never needed to render that. So yeah, what do you use it for? And it turns out, use it for two very, very important things, which we'll get to in just a sec. So yes, basically what a web worker is a thread in JavaScript. Oh my God, they do exist. And they're called workers. And so a web worker is something that allows you to do something in parallel, right? But the problem is that it's not really a thread, right? Because you don't have any object reference. And it's a totally separate process, and it clones data between the two processes, right? So you guys can talk to each other and stuff like that. But it does do parallel things. It does move things off of the main UI thread, right? And those are two things that are extremely important when you have high throughput and heavy computation, right? Remember we talked about sockets, right? In this new world, we are at the mercy of whatever Kafka's doing, which is like super difficult to deal with, right? Low throughput topics, we don't really have to worry about too much, right? But those high throughput ones are extremely difficult to end up dealing with. And so the other thing that we have when we do this, unfortunately, is because we have so much more data coming through the pipe, we now have more stuff in the DOM to render, which means we have bigger messages and more messages, which means that the computation to sort those, let's say, is not something that we ever had to deal with, much less now that I can get back 1,000, 2,000, 3,000 messages per second, right? And someone actually wants to use those, we have now even more computation that we need to ship off to the other pieces of our app. And yeah, so, okay, so basically what we're seeing here, it's a tabular list of data now. That is keyed by however Kafka brings it back. And instead of locking up at 100 messages per second, this thing, now that it's offloaded, locks up at about 125,000 messages, which is the laptop's total max out for the amount of data I could actually get through it. And so with the testing that I did, I actually reached the limits of my laptop not so much the technology that is now used to actually render this stuff, which was pretty cool. And so basically what this is a virtualized sortable list that allows you to see at any point in time what Kafka is doing in reference to these messages. It also allows you to pause, similar to, oh, I'm interested in that one red car. The UI actually will allow you to do that. You just hover over it and it actually gets stuck, which is pretty cool, which is a whole nother set of problems that we're not going to talk about. And then the other thing is a table, right? And so when you think about messages through a topic, right, you end up having this problem of how do you actually key that information and then how you display it, right? And so basically, if you think about a stream of events and stuff like that, with a key, you can easily key by that and then update in place the table that you actually have, as opposed to viewing it as you would in just a regular like consume. And so also wrote that, as you can see. Cool. All right. And so basically what it does is it updates inline based on the key, all of the information that you're actually getting to sort of consolidate it, as opposed to just seeing a list of messages going by. Want to talk a little bit about what I didn't cover. So one of the things that would be very, very useful to do that we sort of don't have time for is looking at the browser perf tools to actually prove that this works. So effectively what we would see is a bunch of data sitting inside of the UI thread. And then we would see sort of a grayish background for all the stuff that's going on inside the web worker. And so I can say, just sort of as a generic thing, WebSockets, at least like the raw messages, come through at microsecond transactions, which is pretty cool to see and be able to handle. The other thing that this sort of opens up is, since we only have like 2 gigs of memory that we can actually have in V8 in a browser at any one time, this actually becomes a consideration that we need to actually deal with on the front end, right? Because if you leave your message browser going through, or it has a ton of information going through, we end up sort of hitting that 2 gigabyte limit actually shockingly fast. And then the other thing that I didn't talk about is the whole stopping time, where you are able to, in the UI, stop everything from happening while still allowing messages to come on top and all that stuff, like from an interaction perspective, to actually know that the stream is continuing, even though you as a user have decided to stop. So I think I hit it, right? Whew. Other than the video, that's it. Questions?
A system, actually, I'm working at my company, where we vacuum up metrics, send them off to another cluster, and then display them on a dashboard. And this seems very similar. I mean, instead of aggregating numbers, you're aggregating images in some say.
Yeah, and so one of the things that actually is, that's actually a good point. And so one of the things that, again, it's sort of a history thing that I obviously didn't talk about is, so this is not aggregation. Yes. And so there are places within like the Confluent app that I work on where we do that aggregation and stuff like that. And so that actually does use long polling, which is where we ran into the problem of if you drop down below a certain threshold on the back end, it just never comes back, right? And so, but yeah, cool. Yeah, and you would definitely be able to use all of this stuff. There's a bunch of use cases that I didn't cover that is going to help us sort of move forward, like with a WebSocket web worker combination, right? That's going to allow us to do a lot more computationally heavy things in the future. Oh, okay. Yeah, and I'll just repeat it if you, whatever.
I guess it's my turn then. So the question I was going to ask, had you considered putting a client-side process, let's say like a JVM that supported like a local browsing experience, so you could get full interconnect between the systems without having to try and force it through the web browser? Okay.
Yeah. So that's actually a really interesting question. And so we did not consider doing that in favor of, we actually have a lot of investment in sort of getting the browser to work from like a SaaS perspective. And so if you have to install a client locally to access the cloud, you're already building in like a ton of friction that is like super scary. And as like the future goes, it definitely makes a lot of sense to stick with the browser, even though, yes, that definitely would be easier, but less fun. sans videos. Oh. Cool. Thank you very much.